Thanks for joining us today. This is the latest webinar in our GeoTalks Express series, and today we're going to cover what's new in the latest release of the software, which is Global Mapper version 23. I'm Katrina Schweikert. I'm a product manager here at Blue Marble Geographics, and I'm joined today by Mackenzie Mills. Hi, Mackenzie.
Hi, Kat. How are you doing this afternoon?
I'm good, thanks. I'm excited to show some of the stuff we've been working on the last couple months here.
Me too.
So first, let's go over a little about how this webinar works. If you want to. So as always, attendees are in listen-only mode. If you take a look at your GoToWebinar toolbar, you should see an option for the questions panel. So we will keep an eye on that, and we'll try to answer questions, related to the content we're covering during this broadcast. If you're watching the recording of the session, you can also send questions to our technical support team. We'll have that contact information at the end. And any questions that we don't get to, we will respond by email, and we also typically post answers to those on our blog. So you can also check out our blog if you're watching the recording and sort of see what some of the questions were related to this content. So you want to tell us about some of our other upcoming webinars, Mackenzie?
Absolutely. So as Kat said, this is part of an ongoing series of our GeoTalks Express webinars. Next week, we sort of have a partner to this week's webinar. This week, we'll be talking about new features in Global Mapper version 23. And next week, we'll be introducing Global Mapper Pro, the next step in development of Global Mapper with some really exciting new tools and functionality. On October 13th, we'll be bringing in Global Mapper Mobile, the mobile application for some field data work and field data collection, and how you can work with that mobile application with Global Mapper desktop and managing data between those two programs. And then on November 17th, we'll do a suitability analysis for grape cultivation, for viticulture, and walk through the workflow of that in Global Mapper with some, applying some of the tools that we'll look at to a workflow here. If you have any questions or you want to find out more information, register for these upcoming webinars, visit our website. They're all posted there with dates and times, and you can register so you get notifications when those will be coming along.
So we also have some training sessions that are ongoing. These are all remote sessions at this point. We're still sort of practicing our COVID procedures here and doing remote training. So coming up soon is LiDAR processing workshop. That is a morning Eastern Standard Time class. And then in November, we'll go through a Global Mapper training class and a LiDAR processing training class. Those are both, I think those are alternating between morning or afternoon sessions for the East Coast, depending on where else you are in the world. You might check those times out at the link at the bottom there. So those are all a couple of day classes done through also using the GoToWebinar format, and we walk through a lot of processes training within the application, so it's very hands-on, and you'll learn how to run a lot of the advanced tools within the software. So check those out. Those are coming up. We actually have a class going on this week, so a little too late to register for that one, but keep an eye out for more classes. We'll continue doing those next year as well.
All right, so jumping into the content for our webinar today, the new features, new tools in Global Mapper 23, I'll briefly go over our agenda and the tools that we'll be looking at. We're going to start with some data visualization, some chloropleth mapping, creating some thematic maps with vector data in Global Mapper. We'll move on to some more visualization options with 3D labels. So there's some updates to better display those text label features in the 3D view, so you can see labeled features in multiple views of your data in Global Mapper. We'll talk about the spatial operations tool and some various improvements that have come into that tool in Global Mapper 23, analyzing vector features, selecting or creating new features based on the spatial relationships between existing layers. Now, this is a highly requested one. Global Mapper now has undo and redo functions in Global Mapper version 23, and we're very excited about that. We'll walk through the basics of undo and redo and show you some of the details of those functionalities. Another user requested feature here is some discrete contour area generation. So a slight update to our contour generation tool based on a user request, and Kat will walk through what that means and what the discrete contour areas are. We'll look at updates to the viewshed tool, so creating viewsheds with multiple points and a checkbox option that'll apply another layer of analysis to that process when you're working with multiple points, streamlining workflows and making things more efficient. We'll talk about an update to digitizing the coordinate geometry tool, so a specific method for digitizing and how notations and the coordinates that you're entering for this digitizing method are stored and can be accessed when the feature is complete. And lastly, we'll get into a little bit of data type conversion here, so creating 3D models or 3D meshes from selected area features, so converting something from just a vector area to a mesh feature that can then be visualized and exported from the program. So some exciting stuff to go over in the next about an hour here. And with that, Kat, I think I'll hand the screen over to you to jump into our first topic here with choropleth mapping.
Awesome. Can you see my screen, Mackenzie? Yeah, looks good. Okay, great. So we've made some updates to how we can make thematic maps within Global Mapper. So to start with, I have just grabbed some of the latest 2020 census data. So the US Census happened in 2020, and thus far, all that has been released is the apportionment data, which, if you're not in the US, is how we determine how congressional seats basically are distributed by each state. So we have a little bit of information that I've brought in here, and I think I actually had to join my geometry data to my tabular data, which is also something that I can do within the program. So what I want to do is to make some maps that kind of explain some of these new statistics and let me have greater insight into this data. And we've made some really great improvements to make really attractive looking maps here. These are typically called choropleth maps, where we're coloring based on a numerical value associated with the data. So we're going to start with just area features here. So I'm going to just double click on the top area layer here. I've got a few different versions loaded just so we can look at some that I've already made. I want to go over to the area styles tab. So we have a few different ways that we can style our data. If you've just loaded something with the default options, you might have this top level checkbox or bullet here selected. So that is going to use the feature types, or if there's any object level custom styles, it will use those settings. So feature types you can set up in configuration. The idea of that is basically like kind of like a CSS for your map. If you want to use the same style every time you have features of a certain class, so you can determine what the style is for those classes. And we have a bunch of built-in ones. You can also make your own. Right now I have just a custom style for this specific layer. So I have set it so all the features are in this gray style with a white border here. The next option down is what we're going to be looking at here. So here's styling based on an attribute or name. And this works with all different types of attribute data. We've also added an option here to jump right into the attribute calculator. So I'll use that in a minute. If you want to calculate new data, based on maybe combining your different attributes or normalizing your data by the area, something like that, we can do that right within the style area here, which makes it really convenient. You don't have to back out of the style and go back to your attribute table to make those changes. So there's quite a few attributes here. The main ones that we're going to focus on are population. There's also a population density that I've already calculated. I think we'll start with that. So the new option here, I actually have forgot to remove these, which were already calculated here. We'll just delete some of those existing styles. Let's go ahead and classify. So I've picked population density as my attribute. It really helps to pre-select this. The classify button really wants to work with that numeric data. So this is going to really only give you good results if you pick an attribute that has numeric values inside of it. You can also pick the attribute once you come into this classify dialog. So if I wanted to switch the attribute, I could choose a different attribute up there as well. So what I'm seeing in the top section of my dialog here is a histogram of this population density value. And so I can change the number of bins, or basically the bars that I'm seeing, if I want to kind of subdivide or show this distribution in a different way, kind of depending on how many bins I've chosen here. What we're going to do is pick a classification method for this. So we have 3 methods to choose from. So a very basic method, equal interval. Let's do 4 class breaks here just for better explanation. So I'm going to do an equal interval of 4 classes. When I hit the classify button, you're going to see where those class breaks are occurring. So these are 4 equal ranges of values, and I'm just dividing up my data sort of 4 different times. If I could change the value in either of these settings and then hit classify again, and it's going to update where those class breaks are. Equal count is going to divide by quantiles. So in the case of 4 breaks, basically I'm getting the bottom 25% of population density, then the middle bottom, and then the next section, and then my upper range, which is quite a large range here, is that top 25% of the most dense places. So this is going to give me a very different map compared to the first one. It's going to show the data very differently. And we'll do that in just a minute once we pick a color ramp here that better represents this data. So we have provided a bunch of built-in color ramps. These little swatches are going to change based on the number of classes that you've selected. So a lot of these built-in styles actually come from some cartographic research in the Color Brewer project. So you might be familiar with this if you have done cartography work. This is some great work that covers, really nice visualizations where a broad range of people, including accounting for color blindness, can really distinguish these classes and be able to tell them apart on a map that is trying to show a lot of data. So these are some really nice styles to start from if you just want to make a nice looking map. In this case, we're doing population density, so we might just pick one that's kind of continuously ranging colors. Where my low density would be a light color and my high density would be a dark color. You can also invert the ramp if that makes more sense for your data. And these go up in number as well. So if we do, let's do twice as many here. There's a corresponding ramp for that many colors as well. So let's go ahead and see what this first distribution looks like. So we're going to go ahead and make sure that's classified for all 8 classes here. I've actually upped my value here. And we'll hit apply and see how that looks on our map. So now we're seeing basically 8 categories of population density for each state. Just to kind of reiterate the point here, we can go back in and change the method. So if I did equal interval and I went and classified that, I would get a fairly different looking map showing, that there's some very high density places and then some, mostly the smaller states, and then some general lower density. So that's showing me a very different picture. It's also worth noting here that this checkbox at the very bottom of my style setup is important. So this is whether or not these are discrete classes or I want to interpolate the colors between my different ranges. So that's going to show me some different, a little bit harder to tell when there's 8 classes, which is sort of a lot. But if you have just a few classes, you'll really see a big difference between whether you're interpolating or not. So if you want just discrete colors that don't vary at all, you can turn off that interpolation. There's one more method that I want to talk about here, natural breaks. So the idea of natural breaks, this is a statistical method, and it's basically minimizing the difference between classes, any of these class breaks or bins, while maximizing the difference between any 2 classes. So this is a statistical method that does this. So this has come up with a different way of dividing this into 8 different categories, and we can see how that looks a little bit different, where we still get, some of our high density, smaller areas, but we also have a different picture of kind of the range of values across the area. So that's another classification option as well. In the bottom of this dialog, you can also choose sort of the default styling properties. So for example, if I want to do, like I did on my original map, I usually like to make my boundary color a little bit lighter. We'll make it a width of 1 pixel here. And just change settings like that as well, right in that dialog. You can also make edits after the fact. So maybe I started with natural breaks and then I want to round off some of my numbers just to make some nicer breaks. I could always update one of these values by editing the value, or edit the style. So you can also bulk edit the style here by just shift selecting all and then editing the style as well. So different ways to change that data once you've created it using the classification. It's kind of flexible in terms of making updates to that style, but this classification dialog really lets you make some nice subdivisions of your data to show this choropleth display so you can understand the distribution of your data better on your map. So that was population density. Let's do one more example. I'm just going to remove the classes for population density. One thing that I found really interesting within this data set is actually looking at the number of people per congressional seat. So within a state, this actually varies a little bit. This is probably not perfect statistics because I'm not actually a demographer here, but just using this data, this is very interesting. So let's make a new attribute here. I want to divide the population by the number of representatives. So I'm just going to make a new attribute here. So I'm not spelling well right now, but population per representative, and then I can use my existing features to come up with a new value. So we'll use the apportionment population as our first attribute, and then we're going to divide by a second attribute, which is the number of representatives. And we can go ahead and calculate this new pop per representative value. So this is now going to show up as the selected attribute, and this is also going to show up in our attribute table. It's now a new column that we've calculated for our attribute table. So let's go ahead and classify this data. And we'll stick with natural breaks here. And we can take a look at, let's actually make a custom style for this. So if I click at the bottom of the ramp drop down there, there's an option for custom. There was a little pop-up that I clicked out of a little bit quickly there, but it was explaining that there's basically two options here. I can either make a palette that represents all 6 of the classes that I need, or I can make a 2 or 3 color palette that is going to interpolate those extra breaks that it needs. So basically I can make a sequential palette by picking a starting and an ending color, or a diverging palette where I pick a start, middle, and end, or I can pick every single color. So let's make our own custom, we'll just make a sequential palette here. I'm just going to pick a color. So let's say I want to start with, let's see, this is representatives per population. We'll just pick a solid color here. We'll start with a light green, and we'll go to a new color here, which is maybe a dark. So that would be lots of high population per the number of representatives. So that's going to make a new color ramp. So based on the starting and the ending color, we've now come up with our own custom color ramp. And let's go ahead and classify that data and apply that. So obviously I could go back and change this with different colors or different classification breaks if I want to, or like I said, if you want to go in and edit these values and just slightly shift them so you modify that statistical classification a little bit to just make some cleaner numbers. That's a little bit common in cartographic outputs as well. So that is working with area features. This also works with point features and line features. So I'm just going to do one more example here. So I've actually taken the same states and grabbed the centroids. So this is a function that you can do with the digitizer tool. If you just select all the features in the digitizer, there's an option to calculate the centroid. So I have done that because in this case, I want to do some proportional circles. So using that classification tool, I want to actually show the population in these kind of graduated circles. This is a really good way to show that raw numerical data, especially when my areas are of different size and it maybe doesn't come through very well when I just use color for the area. So I'm going to click into the style for this layer as well. And we're just going to use the direct population or apportionment population here as our classification value. So we're just going to use the raw number. And let's see, this is population. So we'll again just do sort of a sequential color scheme here, and we can pick a classification method. I'm going to go with, let's go with equal count this time. So we come up with some quantiles here. So I can also choose to scale my value as I go. So if I want to, my starting dot and my ending dot right now are both 8 point size, so I can adjust the point size. I can also apply a scale factor. So let's make the ending dot, 3 times bigger than the starting dot. So based on my breaks, it's gonna calculate that, and it will update the preview here as well when you click classify. So I'm gonna start with a circle this size and end with a circle that size based on these class breaks. And when I hit apply, you'll see that as well. And so again, here's another place to show the difference between interpolating and not interpolating. So when interpolating is on, I have a broad range of sizes. If I untoggle that interpolation button, then I just get discrete categories here of circles. So every dark red circle is the exact same size, and it's just kind of discretely classified into these categories. So one other thing that I will quickly show just in terms of creating maps here, these are not necessarily new tools, but if I want to, I can turn on a legend within the workspace. So under workspace layout options, I can add a map legend on screen. So this is gonna create a vector legend here, and there's some settings for how we display that data, but we can do that right on screen. And then if you wanted to do print mapping, our map layout tool is a great way to do that. I've set this up a little bit ahead of time, but we can add a legend, we can add a title, metadata, all sorts of information. This is the best way to make kind of a cartographic product as an output, where you might want to add some of those additional statistics and lay it out within a page. So this is a great tool for this choropleth mapping workflow as well. So that is our latest addition to the kind of cartographic display of data. So this is a really powerful way to kind of explore numerical data and visualize it on a map.
We did get a couple questions, Kat, that are connected here. So how does this chloropleth mapping, the vector classification, handle data where there's no attribute value in the field?
That's a good question. I actually am not sure I remember that one off the top of my head, but let's see if we can.
I mean, I think
we might have to come back on that one.
I think it was happening with your proportional circle map there, because you see that the Puerto Rico features didn't get updated. They're remaining that default style because the attribute doesn't have a value there. So that's how that would be handled.
Yeah, thank you. Yes, of course. And actually, if we turn on our overview map here, there's actually data for, this is all the US states and territories. So you can see all these other areas that don't have congressional seats are just getting that default style. So in this case, it's an unknown point feature, and that is just a black dot. So yeah, we could configure that in the configuration if you want to, depending on whether you've assigned a feature type or not. It's typically the unknown style there. So if you wanted to come in and change what that unknown point feature is using for a symbol, you could change that as well. Yeah, and I think that covers why Puerto Rico wasn't updated as well. Yeah, there's no apportionment population in Puerto Rico because they don't actually have a representative. We won't get into politics here. The other question, are they auto-populated within the software, the visualization styles? Yeah, so depending on what you've chosen for the color ramp, or let's go back into the proportional circles here. We're auto-populating this box here, which is the sort of traditional way of just custom creating styles for your data. If you just wanted to add a value and then add a style for it, you can always do that manually. You can still do that with categorical data as well. So if you have text data as your values, if you hit load values, you get basically a style that's unique to each unique text attribute. And that had some capability for numeric data as well, but this new classification option really better handles those kind of continuous numeric values like we're working with here with population. So I think that probably covers that one. So Mackenzie, I think you're going to show us a little bit more on the cartographic side, but in the 3D world. So we're going to look at 3D labeling.
Yes, we are. I've got some 3D data up here, so moving from the 2D world into the 3D viewer, we can see that I've got some terrain. It's shaded with just the gradient shader, sort of a nice neutral backdrop for some vector line features that I have laying on top of it. So this is an area of Canyonlands National Park, and these brown line features that I have are some various trails around this section of the park. Now, currently these aren't labeled, and I can easily apply a label to these features in the 2D view. That's not new functionality, but applying some nice looking labels in 3D is where we've really made some great improvements for version 23. So before I jump into creating some labels here, I'm going to quickly jump into my 3D configuration options. And under data display, to show 3D labels, you want to make sure that that show 3D labels checkbox is enabled. This makes it an easy way for you to turn on and off the display of those 3D text features in the 3D viewer here. With that checked, I'll move on to my layer options for my trails layer here. So opening this layer, I can choose to display labels for the layer. And there's a bunch of options here for how you configure that label. I'm using a selected attribute value, in this case, the trail name. You can select any available attribute. You can also use multiple attributes or set up a custom format string with some attributes and then standard text as well. And there's some further options down here for like label priority, which labels will be shown at a zoom level where they would overlap. I'm going to leave everything here pretty much the same. I'll just click apply. And we see that these labels pop up in the 2D view right behind my open dialog here. They are in black text, so they may be a little difficult to see, but they're not showing in 3D view yet. And that's because to create labels styled in the 3D view, you'll want to create a separate label layer. So this was a functionality that was introduced a few versions ago in Global Mapper. And clicking OK after making that checkbox selection, we now have a new layer of text features in the workspace here. And moving these text features to their own layer allows for some greater control over the styling. You can pick up and move individual label features on your map, and we can see them in 3D. So zooming into a little portion of the data here, it's my 3D viewer updates. We can see that we got some text laying on top of our elevation grid. So these are flat styled 3D labels. Part of this 3D label functionality is that stroke value, that buffer in white that we're seeing around our labels in the 3D view. And typical to labeling any line feature, these labels are following the direction of the line features. They're sort of as parallel as they can be to these, curvy trail line features that they're labeling. Now I'm sort of looking at the terrain from up above here so we can see these labels and read them. They're sort of flattened and squished down into that 3D data. And as I rotate the 3D view, we see the labels aren't rotating, so some of them are, upside down or skewed and a little harder to read. Now we can change that style, not only the position of them, but the color and other text feature attributes as well. So I'm going to open the options for my label layer. And again, we can customize what attributes of the data are being used for the label. But I'm going to go about halfway down to the label style options and choose to select a specific style for these label features. Here we can edit the text style in 2D and 3D, so I'll make them bold, maybe a little larger, and select a nice bright color so they stand out against my, gradient white to black terrain layer in the 2D view. And below that text style setup, we have an option for 3D labels. And I can customize the 3D style. And this again is for labels that are specifically in a label layer. That background area, that stroke thickness that we're seeing in white in the 3D view, we can adjust that thickness with higher numbers being a larger buffer. I'm going to leave that at 2. And I'm going to change my display mode from flat, which is what we're seeing right now, to billboard. And this is going to put those labels up in the air, and they'll rotate to always face the viewer, to face the camera in the 3D view. With that, I'll click OK and apply those settings. And we should see that data reload in just a second. We see those labels updated in the 2D, that top-down view that's on my left here, with our bigger bright red labels. And then we have our 3D view, where when I move the data around, pan, maybe zoom a little bit, you see more labels pop into view as they are able to. And these labels are now all, facing upright, hovering above their designated feature, and they're rotating, so they're always able to be read. So this gives us a great view of this, edge of a canyon here. We can see labeled trails as they go up to get a better idea of this area for this sort of rough terrain area.
So we're getting a couple questions, Mackenzie, about labels, and I think I wasn't aware actually that that was such a popular request. I think we'll have to take another look at that. I think at this point, those line labels, they do default to the orientation of the line, but I don't believe that we have a way to curve labels at this point if they are following along the line. I think it's just, it will follow one segment sort of in the middle of the line feature. So we'll have to take a look at more improvements in the future. Another question is if these 3D labels will work in a 3D PDF.
That I am actually not sure about. I have not personally tested exporting these to a PDF. I'm not sure if you know the answer to that one, Kat.
I think we'll have to test that one and probably get back to you, or maybe that's something we can look at adding as well if it does not currently work. I think some of the label export options definitely go into 3D PDF, but I don't know that we've specifically tested, at least I haven't either tested these new 3D labels. So yeah, we'll have to get back to you on that one as well.
Yep, so someone's commenting that some of these trails here are labeled in multiple places. And that's likely because each trail is made up of actually multiple lines that sort of connect together to make a single line. And they're not necessarily just segments of a line, they're actually individual unique features. With the label layer that I have showing here, I can grab my label select tool and I should be able to select, any few labels and delete them to reduce the number of labels that are showing in the 2D view and the 3D view. And that's another advantage of having this separate label layer. You're able to, more finely position those labels and delete the ones that are maybe repetitive or unneeded.
Yeah, and if you do have a multi-part feature that you've grouped together, that's also the label layer kind of automatically handles that. So for example, we were looking at my state's data, maybe I have the state of California that has all the islands off of the coast. If that's a multi-part feature where the islands have already been grouped to the main state, those will just get one label in the label layer. And if they don't, you can always do as Mackenzie is and kind of delete, the extra ones that you don't want. But yeah, there is some handling for the sort of multi-part geometries in that label layer logic. And as Mackenzie was showing, there is also options for prioritizing the labels based on an attribute or based on something about the data that you want to use as a way to show certain labels over others.
And someone's asking just about single label editing. So if I go ahead with my label select tool and maybe, well, that's just the regular digitizer select, select a specific label feature here, I can use that digitizer right click to edit the label text or edit the feature style. And this brings me back to my style options for this one particular label that I have selected. And down at the bottom, there's options to rotate the label, and we can see the current rotation that's been applied based on the line feature that we're labeling here.
Great, so I think we're going to move from the sort of cartographic realm into some more detailed analysis here. So a tool that we introduced recently was the spatial operations tool. And this is a great tool for working with vector data. So we've actually, in the latest version, expanded this to work with points and lines. Initially, it just worked with area features. And so this lets you do things like perform operations on different layers to find, their intersection or their difference, and also to perform queries on our data where we can say, is this layer, or which of the features in this layer are contained inside the features in this other layer, for example. So I've got an example here. We're going to do this on line data. So the latest release has included lines and points in the spatial operations tool. So I've got a railroad line here. You can see the sort of railroad style that I'm using to represent this data, and then also some road features. And so I might want to ask my global mapper here, where are the places where the railroad is intersecting or crossing the road? So I want to find those crossings. So I can go ahead and open my spatial operations tool. And it's going to default to my 2 layers here. So we have a bunch of operations that we can perform here. So the first, I think 5 or 6 here, intersection, union, single union, difference, symmetric difference. These are all operations. They're going to create new geometry. So it's going to make a new layer with some new geometry that is potentially different than the geometry that we started with. It might cut some parts out of other parts, kind of depending on what operation you're doing here. When you select these, you can find also a description about what they are, if you're not familiar with these sort of terminology here. The bottom 6 here, these are spatial predicates. So these are actually performing queries on our data. So for example, with intersects, we would say, I want to find the roads that have an intersection with the railroad. And it would return the entire road section that intersects the railroad. So not just the point of intersection, but it could actually return the entire original road. So that's sort of the difference between the 2 sets of spatial operations that we can pick here. So in this case, I'm going to perform an intersection. So I want to find the point of intersection between my roads and my railroads. Now that we have additional geometry types, you'll also see that there's some filtering options here. In this case, I just have lines in both of these layers that are input, so I'll just leave everything checked. It will know that it's already only comparing lines to lines. In the results section here, I can also filter the output as well. So if I wanted to make sure that I was only getting points of intersection, I could turn off areas and lines here. So for example, if there's a little section of road here that's quite close to the road, if for example, they did share a line segment, I might get part of my result that is actually a line segment, where there is an actual whole segment that is intersecting. So that would change my output. I think in this case, I really only have points of intersection anyway, so I will just leave everything checked here. We're just going to name our output layer here, so I'm just going to call this the crossing or the Xing between the railroad and the road. So I've picked my first layer is roads and my second layer is railroads. In this case, the order doesn't matter too much. There is some handling here of invalid geometries, so I'm just going to use all my data here and see if I can get a result. So let's go ahead and run this on my line feature. So if I turn these off quickly, let's turn off the railroad. You'll see now I have these black points, which are all the points of intersection between a road and the railroad. So I've now identified these using the spatial operations tool, and it's made a new layer for me that is called crossings or Xings. So we can also do this with point features. I have a second set of data here that I've downloaded from the Department of Transportation. This is bridges. So I know that there are some crossings that are actually bridges and they're not maybe on the ground crossings of the road. So, maybe I want to find those ones where there's a railroad and a bridge that are either underpass or overpass. So let's do a query on these 2 sets of points. So this one you have to be a little bit careful because these points, since we are such specific geometry, they have to share the exact same coordinate. So, this gets a little tricky with points, but there are a few cases here where I have my road crossing exactly matching where my bridge point was added, but you do want to make sure that that is true. So let's find, I'm going to call this bridge crossings. And in this case, we're going to take our crossing and intersect it with our bridges. So this is comparing a set of points to another set of points. And so my results will be only the points that are exactly on top of each other between the two layers. So let's go ahead and run that result. And we turn off a few of our data sets here. I think I need to zoom in a bit here, but I've got a few points here. Mainly this is actually the highway, where obviously the railroad does not directly intersect the highway. So I've been able to find those points using the spatial operations tool as well. So all sorts of powerful analysis that you can do with this. I know, Mackenzie, you wrote a really great blog recently using some of these spatial operations tools to do, I think it was it a wind farm analysis for potential, but lots of ways that we can look at areas, lines, points, and how they relate to each other, intersect each other to kind of add intelligence to our data.
Yeah, there's a lot of options with this tool, especially now that you can use all types of feature geometries here to do a lot of different operations and find a lot of different connections within the data that you have available. And just to note, all the improvements that Kat's demonstrated here, they do extend to that spatial operations scripting tab and global mapper script to other methods you can use to execute some of these spatial operations.
Yeah, absolutely. Just looking to see, I think I have some old scripting queries here, but lots of options for scripting the data as well. And you can save those queries if you want to rerun them. So that gives you more flexibility if you want to do, a selection within another selection or something like that. You can move over to that scripting tab. The main operations tool is a great way to just do sort of comparing one layer to another layer and using that drop down and not having to kind of type anything in. Yeah, so this is a very powerful tool for both querying our data and also selecting our data. I'll actually show one more option here. So just let's do the intersects query instead of the intersection, and we'll just go back to the original. I'm gonna go back to my original railroads and roads. And I just have checked on disabled layers because I actually don't have those layers both turned on in the control center. So in this case, if I do a intersects operation, this is a query. So this is gonna find and actually let's switch this. I wanna find the roads that intersect a railroad. So we're gonna put the roads in layer 1. This is gonna create a new selection on my layer 1. And I have options here, so I can actually make a new layer or make a new selection with a digitizer, remove data from my existing selection. There's all sorts of flexibility here in terms of building a more complicated query that's selecting data rather than making a new layer. And so if we run this one, we don't really need a layer name in this case. So this is selected all of my line features that have that railroad crossing them. So now I've got all those segments selected if I wanted to maybe change their style or edit their attributes, but working on my original roads data. So I can also use this tool for querying as well. So yeah, there's a lot. We could keep going here, but yep.
Yeah, I was just going to say we did get a question if you can use attributes to, filter some features through the spatial operations tool, and that is absolutely something you can do through the spatial operations scripting tab. You get a little more complex, but you can use sort of an attribute query to cut down the features in a layer that you're using in a subsequent spatial operation.
Yeah, so you can build subsets of your data. This uses syntax similar to the attribute query tool. There's lots of documentation that covers this. I don't have a specific example ready to show here, but yes, within the scripting tab, you can combine it with an attribute query and do all sorts of different, more complicated operations that are sort of multi-step. So I think, Mackenzie, we can go ahead and take a look at the new undo and redo tool, which is a pretty exciting requested feature that is going to give a lot of workflow flexibility to our users.
Absolutely. We're very happy about the introduction of undo and redo in Global Mapper here. I've got my same workspace up here that we were working with 3D labels. I haven't done any additional work since we last left off here. And undo and redo, they're pretty self-explanatory. You can undo the last operation that you executed and then redo that operation if you would like. These functions can be accessed from the edit menu up here. We have undo last operation, below that redo last operation, and keyboard shortcuts associated with these two options. So Control Z, that classic undo keyboard shortcut, can now be used in Global Mapper, and then redo with Control Y. So, you know, I can undo my last operation, and I can even view, my list of previous operations and pick a specific one from a list to undo. And that is accessed from the undo manager here, also from the edit menu. We can see that my last operation here is deleting selected features. So remember, I deleted some of my specific label features. I can select that, undo that selected operation, and we can see we had a new label pop up right in the bottom left of this screen. Before that, we changed the label styles. Again, maybe I'll use the keyboard shortcut this time. And I'll undo that edit there. So we have our old 3D label style, those flat labels back. These operations, once they've been undone, they immediately populate this redo list, and you can easily redo that selected operation. So these are mainly, changed layer options, deleted features that we are looking at in this workspace. Down at the bottom, I have the initial load of my workspace, not too many moves ago here, where we loaded 2 layers. You can take that undo all the way back to importing layers, loading or creating data that way. Down at the bottom of this dialog, we have some options to just manage the memory, because this tool is recording, all operations that you execute in the workspace in order to have that availability for undo. Down at the bottom, we have a list of the operations that are being recorded. By default, these are all checked off, so all of the available operations will be recorded. These are things like changed layer options, like we saw with the changing of the label style, changing the view projection. So if you reproject your data and want to be able to quickly undo that, you can have that operation record. Maybe not everyone needs to have the ability to undo that change in projection. If that's the case for you, you can go ahead and uncheck that box. Any change in projection, therefore, won't be able to be undone with that Control Z or undo shortcut. You can also bring back a closed layer easily with the undo function, reverse any edited vector or LiDAR data. So that's things like deleting features, adding features, the classification of LiDAR data, changing or editing attributes in vector data. A lot can be encompassed just within that one line of editing vector and LiDAR data. And then loading layers as well. This one refers to, importing layers from a file, loading a workspace, or even the load of a layer, which is the creation of a layer, like creating contour lines or creating an elevation grid or a view shed from, some loaded data. So this seems like a short list right here at the bottom of the undo manager, but it actually encompasses a lot of functionality in Global Mapper, and by default, it will all be tracked, and you'll be able to undo and redo those functions. While this undo manager does exist as its own floating dialog, you can have it open and continue to work in the workspace behind it. But you don't need to have the undo manager open in order to undo and redo any operations in Global Mapper. It's just a way to see that organization and that management if you'd like to customize that further.
So we're getting a question about what operations can be undone. Is it what exactly which things are being recorded? So I think there was quite a long list there. I think we've tried to capture everything, you know, throughout the different analysis tools, anything in the digitizer that's editing, any of the settings changes. You know, there may be a few little things that we've missed that we will continue to put out updates for, but it should be nearly every edit that you make within the application should be tracked within this window.
Yep, and we have an example. Someone asked if you can undo, splitting a line into multiple segments at maybe selected vertices, and that would fall under the editing vector features here. So it would be able to be undone. So, a lot of functionality, almost all the functionality in Global Mapper is encompassed in this list. And again, as Kat said, if you run into anything that can't be undone, let us know. We're always looking to improve the program and improve the tools that we have here. And with that, I think that pretty much
Great.
sums
So
up undo and redo. It's a pretty simple but very useful functionality that I think people will really appreciate having those options in their workflow. I'm going to hand the screen back over to you, Kat, to talk about an update with some contour generation and the creation of areas there.
great, thank you. So that's a great tool for especially people that are working in the digitizer often, or editing LiDAR data, editing vector data. We've also made the next two things that we're going to cover are a lot of improvements to some of our common analysis tools that have been some heavily requested features. So I know contouring is a quite popular function within Global Mapper. And we have made a recent update that we thought it was worth showing since it is such a popular tool here. So I've just got some terrain data loaded, and I'm going to use the Create Contours button up on my top toolbar here. So I'm just going to stick with the defaults here, but we can set up the contour interval, choose what the units are, choose which set of contours is index contours. So, which ones get bolded using these major and minor contours. So the minor contours are going to get, a little bit thicker lines, and then the major, so every 10th contour will get a much bolder line. So you can pick different numbers sort of depending on what your interval is, what makes sense for your data. We can also limit the range. We can change our resolution here. So if I wanted to just upsample my data and really quickly create contours for a very large data set, I could change the resolution here. The new feature here that I want to talk about is this creating non-overlapping ISO height areas. So we can, in addition to creating contour lines, we can also create contour areas. And one thing that was a frequent workflow that was really heavily requested was having contour areas where initially everything within the ISO height area was everything at that elevation and above was going to be contained within the area. But what this create non-overlapping areas features does is actually cut the areas out from each other. So basically, instead of, if I'm going up the top of a mountain, each contour area, rather than sort of a flat pancake covering the whole mountain, kind of getting gradually smaller, would be basically a bunch of donuts, just covering the area that is within that range of elevation. So we're going to do 25-meter contours here, and we'll take a look at this example, and you can see what this new setting means. So again, I've checked generate ISO height area and also create non-overlapping areas to run this new function here. So this is going to create my contours and then basically sequentially go through and sort of subtract them from each other. So the output in general here is going to look quite similar to the original ISO height areas, but if let's take the digitizer tool here and select some different area features. So rather than at this height of, I think I'm at 75 meters here, instead of just things, or sorry, I'm at 50 meters, instead of just things that are 50 meters and above, kind of this whole area, including all these smaller sections, I'm just getting that middle band of things that are between 50 and 75 meters. And if I go up to the next one, I'm just getting the area between 75 and 100. So these are sort of discrete areas now that are not overlapping at all. So this was a commonly requested feature here to kind of cut these areas out automatically. So that is now an option within the tool to do that automatically and create these kind of discrete area features. This creates all of my data in one layer here. So as I think a lot of our folks that are tuned in might be aware of, this is a case where I might want to split my data into separate sublayers. So I'll just show that quickly. If you do want to isolate just these height areas out from the lines, I could do the layer split layer by an attribute, and then just gonna split it based on the type. So that should give me separate sections here for my height areas and my lines. So I have those in different sublayers now if you want to actually divide those out. So yeah, so that's a great new option within that contouring tool, which is a very popular operation for people to create contours. There are a lot of settings in there which are not particularly new that I didn't cover, but I can control the simplification or the smoothness of my output, change which intervals I'm using, change the display of those line features, etc. So all options within that tool, which has been a popular tool for quite a while. But this new option lets you create these discrete contour areas. So that is an exciting option. And I think, Mackenzie, you have a similar thing to show us within the viewshed tool. We've made some updates there to kind of streamline that workflow as well.
Yes, we have. So another option that's been added to sort of an analysis tool, viewshed, like Kat said, to help streamline a workflow is the combining of view sheds from multiple viewpoints. So here I've got a workspace set up with some terrain data for the basis of our viewshed analysis, and then I have 3 points for some fire towers out in Western Massachusetts, and we're gonna analyze the visibility of this area from these fire tower points. So to start, I'm gonna go ahead and select these 3 viewpoints, grab my Create Viewshed tool from the analysis toolbar and just click anywhere in my workspace to bring up this question. And I will choose to create a viewshed at each point, as opposed to creating a viewshed at the location where I clicked. So choosing yes there, we come up with the viewshed setup dialog. Now this looks pretty much the same as previous versions of Global Mapper. This is a great, powerful tool with a lot of advanced options for dealing with maybe some more complex view sheds that deal with Fresnel zone specification and frequency. But we're going to just do a simple view analysis here. We're setting our transmitter elevation or our view elevation at 65 feet above ground. That's the average height of our fire towers here. Our receiver elevation, so what we want to, what we're looking to see from these viewpoints is somewhere 50 feet above ground. So these are fire towers. So this would be just a little bit of smoke rising up that you'd be able to see not too far off the ground here. We'll set our view radius, so how far from each of these viewpoints will be analyzed, to 20 kilometers. And down at the bottom of this dialog is the new option that I want to make sure is checked here, to combine individual viewshed layers. So this process, since I have 3 viewpoints here, is going to actually conduct 3 viewshed analyses, and 1 for each of my fire tower viewpoints. And this checkbox will combine those to create 1 layer as an addition to my output that'll show where those viewshed areas overlap. So I'll click OK, and we'll see Global Mapper calculate through these view sheds. It should only take a few seconds here. We're going to see this calculating viewshed 3 times, once for each of our fire tower points here, and then those viewshed areas will be combined, and we'll get a gridded layer that shows the overlap between the different view sheds. So in the control center, we've got a new group of layers for viewshed analysis. We've got our 3 viewshed analysis layers and our viewshed coverage area. This coverage area is what we're looking at right now. This is the combination of those multiple viewsheds. This looks a little bit like an elevation grid, but we're not actually looking at elevation here. We're looking at the number of viewsheds that cover sort of any given area over this terrain. Based on the legend we have here, we have our blue areas where there's no visibility here, green where one of our viewpoints, one of our fire towers can see, orange where two can see, and then some small spots of red where we have all three of our fire towers that have good visibility in those small overlap areas. So this is a great analysis to take, you know, those three separate layers and just within that one view shed execution, combine them all and get this map showing, you know, where there's maybe the most visibility in an area.
So we're getting a few questions about viewshed here. So one of them, the view angle or the transmission angle options. So that's not a new feature, but you can, you know, instead of looking at all 360 degrees, you can control, you know, maybe the tower, maybe its searchlight or something is only going within a certain azimuth. So that is an option for the starting angle, and then the sweeping angle for kind of what the range of visibility is there instead of a full circle. There was also a question about pulling the attributes from the points, and that is not super obvious in this dialog, but that is actually also built into this tool, and you can look at the documentation to find out more information about how your attributes need to be named in order to have them automatically pulled in, but that is definitely an option.
Yep, there are also options here for transmission angle ranges. So again, for a more advanced analysis than what we just executed here, there are a lot more options in this dialog. And as Kat said, they're all well documented if you're really looking to dive into this tool further.
Great, so we're actually rounding out the hour here. I think we had a few more things that we were going to show quickly here. So I think we're going to cover, if you can keep with us for a few more minutes here, we're going to cover quickly 2 more features here, and then we'll wrap up. Quite a few questions that we had here, so we're going to run over just a minute on time here. So I quickly wanted to show you a new option within the coordinate geometry tool. So I'm just going to pull up the coordinate geometry tool. This is within the digitizer. So this is really for creating boundary features or line features that you know, are using a specific definition. So this might be from a legal definition, it might be a surveyed line, etc. I'm just going to quickly create this. So I'm just going to use the distance and bearing because for us non-surveyors, it's usually easiest to understand. So I have maybe my first section of my boundary here is listed at 100 meters at a bearing of 20 degrees. So go ahead and add a point, and then we'll just add a few more points here. Just change my numbers a couple times here. So this is creating a list of, you know, what I've entered for values here. This might be a complicated boundary definition, you know, within whatever my data is that I'm entering into the database. So I could always save this to a file and load it from a file, but once I've added these points to my map, originally these were just converted basically into coordinates, and they were not actually storing this information that we used in order to create these definitions. So what we've added is actually storing this information automatically as an attribute of this new feature. So when I go ahead and finish this layer, I'm going to just make a new layer for this. We'll call it boundary. And we'll turn off the elevation just so you can see this. This is just a line feature here. If I go ahead and use the info tool, you'll see that I have this new notation attribute. So that has actually recorded all of those specific section, in my case, bearings and distances that I used in creating this line. And if I use this notation button at the bottom, this can also come up as this sort of floating window for this particular notation attribute, which is always this multi-line attribute that you can add to your data. You can actually add a notation to any feature if you want this kind of specific attribute that has line breaks in it and has this kind of more complicated setup that you want to bring up in a dialog. You can always add a notation to any feature as well. But Kogo is now going to automatically store the geometry that you entered and those specific Kogo definitions as part of the feature instead of just converting that into a geometry. So we could reuse those again or reference those again in the future. And one last feature I think, Mackenzie, we're going to sneak in here is creating 3D models from selected areas.
Yes, we are. So the last feature that we'll go over in this webinar here is, as Kat said, creating 3D features from selected areas. For this, I have a tin here, so a network of triangles. These are triangular faces. I could select one individually, but in order to create a 3D model, so a mesh feature out of this whole area, I'm going to go ahead and select all of the faces in this data set here. Now I can do this with just a portion, use a polygon select or just click and drag to select a smaller area of this tin network here, but I'll select the whole thing, and then from the digitizer menu, I'm going to go over to advanced feature creation. And we have an option here to create 3D model from selected 3D areas. So these areas are 3D, and I'll choose that option. A global mapper will create a new layer in the workspace, and this is going to be a mesh feature. So this is actually just one feature representing the whole area here. We can see it's selected by default. I can go ahead and clear that selection, and we see that it's filled in, it's textured with this, default color, since our tin faces didn't have any color to begin with. And this is a 3D feature. Opening it in the 3D view, it looks solid. We can see sort of the texture across this area of terrain, see a lot more detail than if I were to toggle that mesh off and only show that original tin we were working with. We can still see that this is 3D data, but it's a lot harder to visualize and to see, the finer texture within this, terrain area. The mesh feature, can then be exported to any 3D model format. And this is really a tool for, converting data from one data type to another. So taking just those vector area features and converting them into this, 3D model.
So we're getting a couple questions about this. One of them is about assigning a color to the mesh.
Yeah, we can absolutely assign a color to the mesh. I just have the digitizer tool here, and I can click to select, right click, and edit the mesh feature. And it brings up our modify feature info dialog. It looks a little different than those regular vector features because we are working with a mesh, and I can choose the mesh color. So maybe I'll go with more of a dark orange color instead of the gray. Clicking OK to that, we can see it's applied in the 3D view and in the 2D view as well. In the 2D view, since we're at a higher zoom level, we're seeing the triangle network that's used to construct that mesh. That's the actual geometry behind it. And we can view that in the 3D view as well with the wireframe view. And it just allows you to see that structure underneath instead of the smooth sort of textured surface that we're seeing by default. And this is not just a regular, raster-based, pixel-based elevation grid. This is a special kind of vector feature. So you're not able to use, like the Atlas shader or any of the built-in terrain shaders on it, since it's not quite that type of data, although it is, looking quite the same like a 3D surface when we view it here.
Yeah, we're getting quite a few questions about a photo applied to this, etc. You can't do that actually directly with a tin in this case, but we do have options to do that. If you start with a terrain grid and an image, you can actually make a mesh from that has the photo kind of applied to the output mesh. So there are lots of ways to do this. This is just one particular case, and in this case, we did start with data that had triangles, but you can actually do this on rectangular features or any feature types that will actually split everything up into those mesh triangles automatically for you. Yeah, so in this case, we're just looking at the color that we have flexibility with. but yes, the mesh features can have photo textures applied to them. So there's other ways to generate those, or you can edit it as well.
Yeah,
I think
absolutely.
that
There's a
covers
lot to
the
explore with these
questions.
mesh features. Yeah, we are getting a lot of questions, and we're running a little bit over our time, so we don't quite have time to answer all of them right now, but we will be answering them via email. And if you do have further questions about, this webinar, new features in version 23, or, any of your workflow questions in Global Mapper, please reach out to our technical support team at the second email on screen, geohelp@bluemarblegeo.com. We have a team of people, ready to answer whatever questions you have.
Great. So thanks very much for joining us. I think one last thing we wanted to talk about before wrapping up here was, if you have any questions about your order, you can always contact orders@bluemarblegeo.com. This is the latest release of the software, which is version 23. So if you have a license purchased within the last year, you're likely eligible to use this latest version as long as you have maintenance and support. So you might need to request a new license file from us, either by entering your order number or contacting us. But yes, this are our new agreements for licenses. You should be eligible for this latest version, depending on the date within which you purchased.
Yep. And if you have any
So thanks very
questions,
much, Mackenzie.
absolutely. Yeah, absolutely. I was happy to be here. And I hope
Okay, well,
everyone
we'll see you
has
next
a
time.
great afternoon. Thank you.